Happy Tuesday, my science friends. Hopefully you're not out in the really crappy, smoky weather. I checked out weather.com and they use the super scientific term as very unhealthy. That was the rating for today, very unhealthy. Now, I'm not sure I'll see you tomorrow. We'll see, because tomorrow's forecast is extremely unhealthy. So we'll just have to wait and see. All right, what are we going to do today? Well, normally we'd be working on your inquiry assignment, but we need to be together to do that so I can check out what you're doing, give you some tips and things like that. So today we're just going to talk about one of the important parts of science. Is called cause and effect. This is one of those things where you go, yeah, that makes sense. It's not really a mind-exploding idea, but let's look at it anyways. Okay, what is cause and effect? Well, essentially that means if we'll call thing number one happens. Okay, if thing number one happens, it's going to cause thing number two to happen. Okay, this is some super big brain stuff here. Okay. So if one thing happens, it's going to cause a second thing to happen. Now this can keep going. So if this goes, number two happens, that could lead to number three happening, and so forth. Okay. So we're going to diagram your planes using cause and effect. Okay, so get yourself a blank piece of paper. Probably want to have a ruler. Hit pause if you need to. Okay, if any of you were wondering, by the way, what's in the background, that is a quasar. It's usually found black holes. They spin really fast and they are the most energetic things in the universe. We'll learn about those next unit. Okay, so draw yourself an arrow. So before we do your planes, let's make a cause and effect diagram as an example. All right, I'm going to start off. We know the effect. Okay, you always know what the effect is. So in this case, the effect is going to be, this has to do with your car. Maybe you notice your car, one of the effects that you notice is it gets bad gas mileage. Okay, this is the effect of something, and we want to figure out what that is. Now, how we do this, let's think of 4 causes that could be a possible cause of the bad gas mileage. I'm going to say cause number 1, we can put, it could be human error. Or human, let's call it behavior. Okay, so that could give you, that could be a bad gas mileage. So draw an arrow. So this would be cause number 1. Cause number 2, it could be something mechanical. Okay, cause number 2. Let's go up to cause number 3. Now, if it's not something outright broken, it might just be whoever has this car sucks at maintenance. That could be number 3. Let's see if we can think of a 4th one. So far we have human behavior, mechanical, and then maintenance. We could put number 4. Could be the gasoline itself. Okay, so these are 4 causes that lead to the effect of bad gas mileage. Now you can keep going with these cause and effect diagrams. So let's look at human behavior. So the next thing we have to do is figure out what is the human behavior that's giving you bad gas mileage. Well, the most common probably is people have cars and they like the speed. Fortunately, if you like the speed, you get worse gas mileage. That's just the way it goes. One for a mechanical, let's say it's an older car that still has a carburetor, so we'll call it carburation. That could definitely lead to bad gas mileage. Maintenance. Here's a common low mileage cause is the tire, we'll say low tire pressure. That's definitely going to affect it. Now we could have gone maintenance. We could have another one, temperature. You know, cars get better gas mileage in certain temperatures than others. And let's say for gas, we'll say you put low octane. Now, when you go to the gas pump, they always have those, you know, diesel, then they have 87 octane, then they have 93. Usually with the higher the octane, the more the gas is, it's going to be burned. It's going to be more efficient, so you'll get more power and you'll get better gas mileage. Okay, so that is just a simple cause and effect diagram for bad gas mileage. Okay, let's get rid of this. Okay, what I want you to do, and I want you to bring these next class. So on your piece of paper, start off with an arrow. And our effect is going to be short, blind, distance. Okay. I want you to come up with, you should be able to do this looking at the data you gathered. I'm going to draw 4 arrows. For 4 causes of why your plane doesn't fly very far. Okay. So when you show up next time, we'll go over these. So make sure you do it, because we'll take pictures of them, also turn them in Google Classroom. All right, let's look at one last cause and effect that might be a little more fun. It's kind of cool. Let's get rid of space engine. And let's open up Universe Sandbox. So go to Library, Sandbox, hit play. Universe Sandbox is perfect for cause and effect. All right, good place to start, the solar system. So we can talk all about cause and effect here. I mean, quite simply, if I were to go like this for our diagram, and for an effect, I'd put the planet's orbit. Let's slow this down a little bit. Mercury's buzzing around pretty good. Oops. There we go. Okay, so if you look at the orbits, what's the cause of the orbits? They're basically round. They're actually an elliptical, but they're kind of circular in nature. They're all going the same direction is another effect. They're all pretty much on the same plane, not perfect. What is the ultimate cause of this type of orbit? Well, you can probably guess. It's the sun is the cause. Okay, great, that makes sense. Everything orbits around the sun, but why? Well, we could put some more arrows into here. Mainly it has to do with the sun's mass. It's so much bigger than everything else, it overrides the planet's gravities. So the planets don't really affect the sun because they're just not big enough. Okay? So the greater the mass, the more gravity. Okay? So we have the mass. Also, the sun is the rotation. All the planets rotate the same direction as the sun. So that's an easy one. Just looking at the orbits, cause, effect. All right, let's finish up with an artificial cause and effect. Something that's going to happen, but not for billions of years. All right, let's zoom in on Earth. Let's find it. Mercury, Venus, there you are, Earth. How you doing? There it is, spinning, following the sun there. Let's look at some stats of the Earth. Specifically, I want you to look at right here. The average surface temperature of the Earth is 13.5 degrees Celsius. So we can change that to what we're more used to. Let's change it to Fahrenheit. So 56.3 degrees Fahrenheit for the entire globe is the average surface temperature. Now, if we were going to do cause and effect of that, once again, it's the sun, but there's a bunch of them we got to say. So if we drew our diagram here. Let's slow this guy down a little bit. So the effect is 56.3 degrees Fahrenheit. So what are some causes of this? Well, we'd say solar energy. And still talking about orbits, we would say, actually, let's erase that one. Now, how does that solar energy change? Because if it didn't, it'd be the same temperature all the time. Well, things that change the solar energy is the orbit. Specifically, I mean, if here's the sun, that's a terrible sun, and the orbit is elliptical, that means it's not the same distance. When the planet is here, it's going to be a greater amount of solar energy than when it is over here. You would get less, so the temperature would change. Okay. Another thing that affects the temperature of the Earth and solar energy is the surface. For instance, snow reflects more solar energy than the sand would. So the sunlight doesn't actually heat up the atmosphere really. It's when the sunlight heats the ground, and through convection and conduction, it heats the air above it. Also, another thing that affects 56.3 is the season. Okay, we have these seasons. Now, what affects the seasons? The tilt of the Earth. Okay, we're almost at fall. Okay, and it's getting cooler and cooler. Like today, look at it. It's not because summer's over, but 63 degrees. Okay. All right, so cause and effect, we can use it for everything. Meteorology, oceanography, astronomy, geology. All right. Let's go back and look at the sun. I'm going to go for the ultimate cause and effect. Now, billions of years from now, the sun's about halfway through its lifespan. So in about another 3-4 billion years, the sun's gonna die. It's gonna go nova. That means it's gonna swell up, get too big, and collapse upon itself and explode. Well, let's see what. So the cause would be the sun exploding. Let's see what the effect is, as in the temperature. So what's gonna happen to the Earth if this were to happen? Okay, I'm going to slow it way down even more. If I slowed it down to a 1-to-1 time, it would take the energy from the sun a little over 8 minutes to get here. Okay, so quite simply, we're going to blow up the sun, see what happens to the Earth. So keep a look at temperature. Go to my evil overlord tools right here. So tools, explode. There it goes, on 3. 1, 2, 3. All right, so let's zoom out, see what's gonna happen here. So the temperature hasn't changed yet. Now we have this huge amount of plasma racing towards the Earth. Here you can see it, just a wall of it. Let's speed it up a little bit. It's hard to tell how far away it is. So there it is, massive. Okay, temperature hasn't, so the cause was the sun exploded, it went nova. We don't have an effect yet. It would take us about 8 minutes real time to get this, a little over. Let's speed it up a little bit more. Here it comes. Let's slow it down. Okay, look at the temperature, it's starting to rise. The first bit of plasma just getting to the Earth. So definitely the cause was supernova. One of the effects is rising temperature, which is going to cause another effect, probably evaporate the oceans. One big effect that'll really bother us is we'll all be dead. Okay, let's speed it up a little bit. It's already up to 400 degrees. Uh-oh. It's not looking good. – 3,000 degrees. We're almost to the surface of the sun. See if we can see anything left there. So all the oceans are gone. Zoom out again. We are definitely in it. Earth is starting to look kind of like a star. So 10,000 degrees, hotter than the surface of the sun. So there'd be nothing left on the planet now. Uh-oh. There it goes. Earth is gone. Cause and effect. See what the cause and effect of Jupiter was. You can see it right there. Jupiter's not looking good either. It's got this different effect on it because it's gas. Or it's just glitching out. Anyways, there you go. Cause and effect, important part of science. It is science. I'll see you guys when I see you, because I am out of here.